In this video, I want to show you how to set up different types of tests for a Rust project. So we're going to look at unit tests, integration tests, and benchmark tests. So I've set up a simple project, so we've got something to write tests against. Just quickly talking through what it does. The first argument is pulled out of the input arguments, and we look for that as a substring in the rest of the arguments, and then it prints out the count. So the easiest way to see what that's doing is probably just to run it. So if we look for the word of inside sofa, soft, cat, and professor, that should print out 3. There we go. So that's all it does. Let's go ahead and test it. Luckily, unit tests are the simplest case because we use these all the time. So in whatever file we're working in, we can just create a new module called tests. And then we need to make sure that's only compiled in when we're testing. So we say, if the configuration test is currently turned on, include this code. And then we can create a test for count substrings. In order for that to be a test, we need to mark it with the test annotation. And you can see that's then recognized by my IDE. And we can then say count substrings, and we'll try and use a similar example to what we did on the command line. So we'll find the word of inside professor. That needs to be a string. And then into iterator. And then we can check that the count is equal to 1. So that should pass. Let's just quickly run those tests. We do that with just running cargo test. Excellent. So that passes. That's unit tests. Let's looking at setting up integration tests. I deliberately set up a binary crate rather than a library crate because it makes integration testing a little bit more complicated, and it's a really common case, so it's worth knowing about this. So if we have a library project, we can just set up integration tests. We can import from the library as though it was an external library and just write tests against that code. But for binary crates, we can't do that. You can't import from a main.rs file. So what you do instead is you split your project between a main.rs that has pretty much just the main function and calls something to kick off your main code. And then you put everything else in your library files so that you can pull those into integration tests and test against them. So I've already moved the project around to show how that works because it's a little bit fiddly. So let's jump back and have a look at that. Things look a bit different now. So I've really slimmed down the main function. So we're still reading our input args and printing the output, but the code that was dealing with breaking up the input into the first argument and the rest of the arguments and calling our count function has been moved out into its own function. So if we follow that through, that's in this internal library now. So we have our main RS, which is still the binary that will get built and run when we run this with cargo run or when we build it for release. But inside that, we've got this app and a library inside it. You can call this anything you want. The way it's referenced is just through the cargo toml. So I've told cargo to look for an extra library. I've called it app, and I've put it inside source app lib.rs. You can lay this out however you want. This just takes a path. I just think it makes sense to put that in its own folder so that you can see it separate from the main binary. So the function we already had, count substrings, that's just been moved into here. This code in the match block here is the code we already had. So it just breaks up the input, calls the count function with the first and the rest of the arguments. And then I've also moved the tests because it makes sense to keep the tests close to what they're testing. So I've just moved that into the library as well. And then the last bit is to actually write a test. So you create a tests directory, and each file within that gets treated as its own test. So cargo will build that file as a binary and run it. So if you have multiple tests in here, each one will become its own binary target that Rust will build, or cargo will build even, and then it will run them one by one and report their output. So let's go ahead and add a test in here. Just call it test run. Doesn't matter too much, we're only going to write one test anyway. And then you mark it as a test like you would if you were writing a unit test. So everything about this is really the same. It's just what the scope of the test is for and what you've got access to. So unit tests are good for testing individual functions or structures or pieces of behavior. Functional tests, you've got a bit more scope to run slower things or to access the whole project or to run like larger scale tests. And the reason for separating them out is largely just to be able to run them separately. So you might want to run your new unit tests while you're developing because that's fast. And then your integration tests are there to check that everything works after all your unit tests pass. So we should be able to import, what did I call this here? Run with strings. There we go. And then we can pass in an iterator of strings. So we can say, same example again, of and professor. Each of those need to be strings. And then we can convert that to an iterator. And then we can say let count equals, and we'd expect that count to be 1. There we go. So let's run that with cargo test. And just running cargo test on its own should run both our unit tests and our functional tests, or our integration tests. Cool. So test run is passing, and it has also run our internal unit test for counting substrings. So that's unit tests and integration tests. Now let's have a look at benchmarks. Setting up benchmarking is a bit more complicated. So it's currently possible to do benchmarking with third-party libraries, and one of the ones that the Rust documentation points you at is Criterion. So that's definitely an option. There is going to be benchmarking built into Cargo Bench, which is currently available. It works on stable Rust. You just can't run the benchmarks on stable Rust. So the command is there, you can try and run it, it'll just complain that you're using unstable features. So I've done some of the setup already so that we don't have to worry about that, and I will just show you what I've done. So I've said when we are in test mode and we're seeing the feature bench is enabled, then we'll turn on the feature test. So this means our code will still build and run on Rust stable. When we run on Rust unstable and we turn on the benches feature, we can then use this test feature coming from Cargo, or coming from libtest really. So I've added the same thing here to say when we're testing and when the benches are enabled, import our count strings like we did in our other test module. Then we're going to reference the test crate, and we're going to get the bencher from it. So that is all the setup we need. Now let's see how we put that together to write a benchmark test. So rather than creating a test, we create a bench, and then we will just say bench, and then we'll call it the same thing, count strings, count substrings even. And then we need to take a bencher into that, so that is mutable bencher. And then the way that we let Rust, or Cargo, the thing that's running this, run the thing lots of times and see how it behaves on different iterations is to do b.iter, and then we pass it a closure. And then we can put our test code inside here. So we could take something very similar to this, and let's just add a few more strings here, and let's tidy that up a bit so we don't have to keep calling 2 strings. We'll just say map that whatever value we get, we convert it to a string, and then we can just put raw values in here. And we'll just say cat, hedgehog, car, van, something else with of in it, sofa, just so we have a bit more data. Okay, that should be all we need to do. So it's going to come in, run our closure lots of times, find out how well it behaves on average, and then tell us how well our code performs. And this is such a small piece of code, there's not a great deal we could do to optimize it. Maybe there's a few little things, but really this is just to see how you set up benchmarks and run them. So let's go ahead and see how this looks. So you should be able to just do cargo bench, and then we need to turn on the benches feature to make this work. And I haven't added the feature yet. Let's add that in here. Features. What did I call it? Benchmarks? Benches. Cool. Let's try that again. And it is not happy because I'm running on stable. So that's what I was saying. We have to be on nightly. So rust up default nightly. We'll swap out our toolchain, and then we can run it. And it takes a moment because it's running it lots of times. There we go. So apparently that took 689 nanoseconds, so pretty fast with a little bit of variation. But down at that level, that doesn't really matter. So there we go. That is the 3 main types of testing. So there is one more thing you'll see in the output here, or not on this one, if I just run cargo test you will, which is doc tests. So I'm not going to show those because those are not really tests in the same sense, but if you were to create documentation in your code and put code examples in those, Rust will run them which is a really nice feature of Rust, so it makes sure that as you update your code, your documentation stays in sync. But not for this video, maybe something we'll look at another time. So hopefully you find that useful, and hopefully you'll set up tests on your next project.